Hello and welcome to Data Management, the Good, the Bad, and the Ugly. My name is Jason Pohl. I lead up the Data Management Subject Matter Expert Group here at Databricks. And I'm going to be joined today by Amit Kara, who is Director of Technical Product Marketing here at Databricks. He's going to be walking us through some of the demos throughout today's presentation. In today's event, we're going to be covering data management, the importance of it, the process involved, the challenges that data engineers face, and how Databricks helps with the data management end-to-end. Before we begin, a little bit of housekeeping. Today's session is going to be recorded and will be available on demand to anyone who is registered. We'll finish today's event with a live Q&A, so please feel free to use the Q&A box to put your questions in there, and we'll do our best to answer your questions throughout the event or live at the end of the session. So why are we talking about data management today? First of all, I'd like to define what data management is because it's a bit of a broad term that gets used differently in different organizations. So we believe data management encompasses all the disciplines that are related to managing data as a valuable resource for your company. This includes collecting it, processing it, governing it, and doing so effectively, reliably, and cost efficiently. Given the changing work environment with remote work, we're starting to see an increase on the importance of data management across all companies. According to Gartner, the shift from centralized to distributed working requires organizations to make data and data management capabilities available more rapidly and in more places than ever before. Consistent and reliable flow of data across people, teams, and business functions is crucial to survival. The value of all this data is increasingly being realized by the application of artificial intelligence. Businesses across all industries are disrupting markets by using data to make strategic decisions. We've got a couple examples up here. First of all, H&M, who's a clothing retailer. They're using Databricks to analyze customer purchase and return history, and then use machine learning to predict which products will cater best to each market. And they can do this right down to the store level. ABN AMRO, one of the top banks, is using Databricks to transform its operations to become a personalized and secure bank for the future. They've got over 150 machine learning projects that are being deployed into production right now, and they're doing so 10 times faster than they were able to do before. These include all sorts of use cases from fraud detection to customer service to making recommendations. Finally, JB Hunt is a transport and logistics company. They're looking to enable North America's most efficient freight marketplace. They're using predictive analytics to support load capacity and route optimization. They generate 6.4 billion load recommendations, and they're doing so over 99% faster than they were able to do before. These are a few of the success stories up here, but despite the allure of AI, most enterprises are really still struggling to succeed with it. In fact, we kind of call this the 1% problem. So only 1% of enterprises are truly successful. And these include, the web scale organizations you'd expect, the FAANG companies like Google, Amazon, Uber, Netflix, and Facebook. They're really able to achieve AI at a large scale across their business. A big reason for this is they have massive repositories of data they've been accumulating and armies of data engineers and data scientists to throw the problem. The other 99% of the companies in the world really struggle with this. And the biggest part or the biggest challenge of AI that people struggle with is not the algorithms themselves or building these models. It's really the data. The bigger the organization, the more likely the data is to be fragmented across different systems. The data is not easily discoverable to the groups who may get value out of it. And these data silos are preventing collaboration. And if they're siloed off, they're also promoting the duplication of those same data sets, which is going to slow innovation. And it's also going to make it very hard to govern. According to Forrester, up to 73% of company data goes unused for analytics and decision making. The data infrastructure that's needed is too complex and expensive to manage effectively for these advanced use cases. A lot of the time, the responsibility for standing up and maintaining all this infrastructure falls onto the data engineers themselves. So just to kind of explain it more, let's take a look at the architectures that are typically employed to handle all these different use cases. The challenge starts with the architecture. I've got 4 different types of different use cases here, and you need to build, historically, people have been building 4 different technology stacks to handle all these data workloads. They're very different technologies, and they generally don't work together very well. This architecture complexity is further hampered by the overall ecosystem. So as you see here, as we build this up, there's tons of different tools to power each of these different architectures. It's a whole slew of different open source tools you have to connect, And in the data warehousing stack, you're often dealing with proprietary data formats. If you want to enable advanced use cases like machine learning, you have to move data across the stacks, and it ends up being very expensive and resource intensive to manage all this. Furthermore, like the governance of duplicating this data and making sure that it's only being accessed by the right people at the right time is very hard. All this complexity is being felt by your data teams. Because the systems are siloed, the teams have become siloed too. And you can see, these firewalls in between the teams at the top. What that means is that the communication across them slows down, it hinders innovation and the speed of which you can deliver value out of your data. Different teams often end up with different versions of the truth, which leads to people not trusting the data. And the result is multiple copies of the data, no consistent security or governance model, closed systems, disconnected, less productive data teams. The core problem is the technology that these stacks are built upon. So I'm going to talk a little bit about data lakes and data warehouses. So before I get into, we're going to talk about today with data management, let me give you a bit of history on the evolution of data management. So first of all, you've got data lakes on one side and data warehouses on the other. Data lakes and data warehouses have conflicting benefits, and they've often required, they've coexisted so that they can kind of deliver the best of both worlds in modern enterprise environments. So data lakes, they do a great job supporting machine learning and artificial intelligence. They have open formats, and there's a big ecosystem around this that people have been using. However, they have poor support for business intelligence, and they suffer from complex data quality problems because there's been a lot of issues with trying to write distributed data sets into these data lakes and making sure you're not duplicating data when doing so. And you haven't had the performance on top of them to really support the BI queries. Now, on the other side of the spectrum, you've got data warehouses. Data warehouses have been around for decades, and they're great for business intelligence applications. They're very good at loading structured data sets. They can have more or less predefined queries that run on top of them and optimized for that. However, they've got very limited support for machine learning. They typically are built on proprietary platforms, and you can really only interface with them via SQL. So, what a lot of companies have been doing is they've been standing up and using both of these different systems to support these two different use cases. If you can unify these systems, we can be transformational in how we think about data. So this is why Databricks has invested so much in the Lakehouse to provide one platform to unify all of your data, analytics, and AI use cases. The key enabler behind this innovation for the Lakehouse architecture is Delta Lake. We've seen this paradigm come to life across many organizations in all industries. Every major cloud provider has been espousing the benefits of data lakehouse architecture. Even luminaries such as Bill Inman, the father of data warehousing, has started to promote the benefits of this new architecture. This diagram I've got on the screen right now is in fact from a recent blog that Bill published on the importance of the data lakehouse. And we talk about lakehouse being adopted across every different industry. More organizations than ever before are adopting the lakehouse to achieve their data goals. Digital natives that bet their business on data are adopting it. So for example, Samsara collects and processes more than 2 trillion IoT data points annually to optimize the logistics industry. And Grammarly is applying natural language processing in real time to help make our emails read beautifully. Large enterprises are also quickly adopting the lakehouse architecture to help streamline their businesses. We've got a whole bunch of logos up here, but just to call out a few: Shell, Ford, Condé Nast, McDonald's, and Halliburton are just a few of those. Now that I explained what a lakehouse architecture is and the benefits, let's dive into what the lakehouse platform looks like on Databricks. The Databricks Lakehouse platform is unique in 3 different ways. Number 1, it's simple. Data only needs to exist once to support all of your workloads on one common platform. So you just have to write your data once, and then you can read it and use it many times over. Number 2, it's open. It's based on open source and open standards to make it easy to work with existing tools and avoid proprietary formats that end up locking you into technology that you cannot migrate off of easily. Number 3, it's collaborative. Your data engineers, data analysts, and data scientists are able to work together much more easily than they ever have before. More importantly, they can collaborate securely. We ensure that the right data is available to the right people at the right time. Databricks is the data and AI company. No one else can do what we do with a single solution. Now let's explore this a little bit more. The key enabler of the Lakehouse is Delta Lake. Delta Lake provides the ability to build curated data lakes that add reliability, performance, and governance that you expect from a data warehouse, but directly on your existing data lake. You gain reliability with ACID transactions. And now you can be sure that all operations in the data lake either fully succeed or fail, and the ability to easily time travel backward to understand every change you made. This means that you can basically run a query today as your data looked at a point in the past. Additionally, Delta Lake is underpinned by Apache Spark. It utilizes advanced caching and indexing methods. You can process and query data on your data lake extremely quickly and at scale. Finally, Delta Lake provides support for fine-grained access controls, giving you much more control over who can access what data in your data lake. There's no reason you have to have two separate systems now, because you can have all the security, reliability, scalability, and performance in one system. One of the core workloads for Delta Lake is ETL. It's one of the most critical data workloads because data quality affects every downstream process. As new data is brought into organizations, data engineering teams have the job to process this messy data into clean, fresh, reliable data to fit the use cases it's intended for. Often this gets represented as a clean flow. But the reality is not so simple. The exponential increase in data sources and types happening inside enterprises today mean that building and maintaining these reliable data pipelines has become one of the more challenging parts of data engineering. The fragility of it all creates a huge challenge for maintaining reliability. If pipelines fail, it has a huge downstream impact on all the systems and the teams that rely on that data. This makes poor reliability extremely expensive. From the start, implementing these high-quality pipelines has been slow and difficult. They are built with complex code, limited reusability. It's hard to trust the data quality sometimes. Bad data is often allowed to flow through a pipeline undetected, and then it usually doesn't get noticed until an executive notices that something doesn't quite look right in a dashboard. To maintain quality and ensure reliable insights, data engineers are required to build boilerplate code to implement data quality checks and validate every step of the pipeline. As pipelines grow in scale and complexity, companies are often faced with increasing operational load managing them, which makes data reliability incredibly difficult to maintain. The processing infrastructure for this that has to be set up, scaled, restarted, patched, and updated, it translates to an increased time and cost. So large-scale ETL is complex and brittle. It's a complex pipeline development, hard to build and maintain these end-to-end ETL dependencies. It's difficult to switch between batch and streaming in a lot of platforms. There's poor data quality and reliability. This means it's difficult to monitor and enforce data quality and impossible to taste the data lineage sometimes. Number three, there's difficult pipeline operations. So there could be poor observability at a very granular data level. And the error handling and recovery can sometimes be laborious, especially if you have to build it all yourself. So some of the solutions we have to this is one of the things is autoloader. If you start at the beginning of a data pipeline, the point where you're ingesting data, with autoloader, you get easy and scalable incremental file processing. And this is done for both batch and streaming. Autoloader is going to incrementally process all the new files as they arrive on your cloud storage. It's done by leveraging the notification services and queues that these cloud storage services automatically provide. And you don't have to go in and set up these things yourself. Autoloader will automatically set up the necessary notification and queue services for you. Because it can effectively track the new files that are arriving when they arrive without having to repeatedly list all the files in the directory, it can scale to millions of files in the directory. Finally, as you're ingesting these files into your pipeline, autoloader can automatically infer the schema and the source of the source data. And then as that schema changes, it'll evolve it as it loads it into your Delta Lake. Next is Delta Live Tables. Once you're loading this data into Delta Lake, you're going to be doing other transformations on it. And Delta Live Tables is the future for how to do these. It's a new service on Delta Lake that makes reliable ETL very easy. It helps data engineering teams simplify ETL development, improve data reliability, and scale operations. It has unique capabilities involved in ETL as a managed service. So number one, it has turntable latencies that allow you to run pipelines in either batch or streaming mode. It has easier error handling and automatic recovery from errors. It has built-in data quality controls and tools, so you can actually, observe and take note of any sort of violations of data quality expectations as the data is flowing through the system. And it has deep observability into pipelines for simplified operations. To bring this to life, I'm going to pass you over to Amit now, who's going to take us through a demo showing data ingestion and processing on Databricks.
Thank you, Jason. Hello, everyone. My name is Amit Kara, and I am the Director of Technical Marketing here at Databricks. Today, I'm going to show you how data engineering teams can leverage Databricks Delta Live tables to simplify ETL development, improve data quality, process data at scale, and manage reliable data pipelines that deliver high-quality data for analytics, data science, or machine learning use cases.
For this demo, I'll show you how to build Delta Live Tables pipelines in a notebook, which is an integrated and unified web-based interface that contains runnable code, visualization, and narrative text for data engineering, data science, machine learning, and SQL analytics. Now, in many cases, the biggest challenge data engineers face is efficiently moving various data types such as structured, unstructured, semi-structured data to the Lakehouse in a timely manner. With Databricks, data engineers have three ways to ingest data into Delta. One is a partner integration network. The second option is a simple SQL copy command. And third is an intelligent autoloader. So let's show you how a data engineer can use the autoloader feature to efficiently move data to the Lakehouse. The data engineer can simply create a table and point to the location where the files are stored. In this case, it's a directory for JSON files. To make it automatic, the data engineer specifies Cloud File Source Format, which is a simple semantic that takes any file stored in cloud storage, either AWS S3, Azure ADLS, or GCP, and automatically ingest them regardless of the variety, the veracity, volume, or velocity. As new data arrives, the autoloader will incrementally and automatically load data into the Lakehouse without any extra configurations. As raw data is ingested into the Lakehouse, the data engineer needs to transform and cleanse the data. Using Delta Live tables, the data engineer can build declarative data pipelines using SQL or Python within a notebook. So in this demo, we're going to follow the medallion architecture, going from bronze to silver to gold layer. Here we have three temporary live views created as reference views, followed by the bronze table where data standardization and integrity rules were applied. Notice the syntax temporary. This is a keyword that marks the view or table as temporary, which acts as a temporary intermediary object and is not published for external consumption. The live syntax referenced throughout the data pipeline refers to the runtime mechanism of how Delta Live Tables understands the queries and analyzes the pipeline to build lineage of the data flow. Since the data flow is expressed in an environment-independent way, there is no schema prefix required. The data flow reads from the virtual schema. This allows the data pipeline to be deployed in a staging, QA, or production environment with no underlying code changes. Next, data quality and integrity is essential in ensuring the overall consistency of data within the Lakehouse. Fundamentally, data engineers need to embed data quality validation checks into the data pipeline. However, applying data quality isn't as simple as adding formulas to determine if the data is correct. Within the data flow, data engineers can specify data quality expectations on how to handle bad data. For example, the bronze layer expects the date columns to be not null with certain date ranges, and if this is not met, the row will be dropped. Depending on the criticality of the data and validation checks, Data engineers may want the pipeline to either fail completely or flag the issue, or move the records into a separate reject area, or continue processing. All this information is captured within the event log. Additionally, Delta Live tables offer extra control to the pipeline by allowing table level properties to be set on views or tables that have been defined. So for example, tables that have been defined in the bronze, silver, gold could be published to the metastore and made discoverable and visible for downstream use. The data engineer just has to set the table name. Optionally, a list of column names can be specified to z-order the table, or if a full refresh of the table is allowed, or even the minimum interval for updating the pipeline. For each query, the data engineer can document a description of what the query does, allowing other data engineers to discover and understand the context of the underlying pipeline. The data engineer continues to build Delta Live tables pipelines through the medallion architecture. In the silver zone, data is refined and optimized for analytics or data science use cases with business logic applied or feature engineering. Deeper analysis is done in the gold zone, where analysts are empowered to derive newer insights. For each query, the live keyword automatically captures the dependencies between the datasets defined in the pipeline and uses this information to determine the execution order. With this dependency matching, at runtime, the correct version of the table or schema are substituted based on the environment that the pipeline is executed in. Now that this ETL data pipeline has been defined, let's go ahead and execute on this workload. The main unit of execution in Delta Live tables is a pipeline. And a pipeline is a graph that links the data sets that have been defined by the SQL query or the Python code. To create a pipeline, simply go to the Jobs, select Pipeline tab, and create the pipeline. The data engineer provides the name, the path to the notebook, the storage location, and specifies the mode of execution. Mode of execution can either be a triggered pipeline, which updates the tables in the pipeline when the data is available and stops the cluster, or a continuous pipeline, which updates the tables continuously as input data arrives or changes. Once the pipeline is created, we can go ahead and start it. This is where Delta Live tables understands the full graph of the pipeline. Delta Live tables understands the semantic of all the transformations and automatically manages the infrastructure and everything needed to run the pipeline in a serverless manner, leveraging the highly performant compatible compute engine that automates the creation of the cluster optimized for Delta Live tables, providing an efficient way to process data at scale. Delta Live tables automatically connects the data flowing through the pipelines, automatically testing the data and providing real-time updates, and in event of a failure, relaunches the pipeline. The data engineer can view pipeline processing details, which includes a visual view of the pipeline graph and schemas, and record processing details such as the number of records that have been processed and records that have failed validation. The data engineer can see the raw event details as well. This includes the number of records processed, where the pipeline is running, the name of the different flows, the schema that is being produced, the query plan, and the data quality metrics. All of this information is stored in an event log that can be queried. To visualize the data quality metrics and validation checks, the data engineer can create a report or a dashboard that references the underlying event log table for the particular pipeline that just ran. In this case, the data engineer can see the quality of the columns from the bronze zone to the quality per data set or how many records have passed or failed. Finally, for any data management use case, orchestration is an important feature. Delta Live Tables pipelines can be orchestrated with Databricks jobs, enabling automated support for running end-to-end production-ready pipelines. Jobs can be run as notebooks, scripts, jars, Pythons, but in this case, we've selected the pipeline that was created. Jobs also includes a scheduler that enables the data engineer to specify a periodic schedule for the ETL workloads, which will be executed according to that specified schedule. Jobs can also be set up to send notification when the job ran successfully or if there's any failures or issues with that ETL workload. To conclude, you have seen how Delta Live Tables abstracts complexity of managing ETL infrastructure by automatically maintaining all dependencies across the data pipeline and reusing data pipelines with environment-independent data management. This allows data engineering teams to focus on rapidly and easily building end-to-end reliable production-ready data pipelines using only SQL or Python with visibility for monitoring and recovery. And back to you, Jason.
Thank you very much. The Data Lakehouse architecture supports all of your use cases from AI to BI. Next, I'm going to walk you through how Databricks elevates your business intelligence or BI use cases. With data ingested and processed, now you'll want to consume that data for downstream data analytics. At the Data AI Summit in 2020, we announced a new product targeting SQL and BI use cases called Databricks SQL. The approach we have taken is different from the traditional data warehouses. Rather than taking a closed approach to manage data, Databricks SQL relies on the Lakehouse paradigm to store and govern data in an open way. This way, it shares the same underlying storage and governance with the rest of the use cases, such as data engineering, data science, and machine learning. I want to give you some updates on the progress we've made since we first made that announcement. SQL is an important part of the Lakehouse, and there are a lot of capabilities that go into offering a great BI and SQL experience. Our vision for Databricks SQL is very simple. We want to provide the most performant, the simplest, and the most powerful SQL platform, full stop. And we will do this in an open way, so open doesn't come at a cost. Last year at Data AI Summit, we also announced Photon, our new vectorized query engine. It's able to provide extremely fast query performance on data lakes, allowing analytics workloads to run directly on the data lake at scale. It's built from scratch in C++ for high performance, and it still leverages the Apache Spark APIs. So with Photon, customers can run workloads 10 times faster without losing the expressiveness of Spark. To illustrate this, we partnered with the Barcelona Supercomputing Center to run performance benchmarks against Photon and the major cloud data warehouse providers. We used the industry standard TPC DS 30 terabyte scale benchmark, and we're proud to show that we have already beaten all these cloud data warehouses to offer the best price performance. We're only just getting started. You no longer need to export data from your data lake just to load it into a data warehouse to obtain top query performance. With Databricks, you can write your data once into the Delta Lake and then query it many times without duplicating data across silos. The goal of all this is to provide the best price performance for all SQL workloads while retaining all the benefits of an open platform. Fast query performance can be achieved on queries both large and small now. Query queues are used to ensure that large queries do not block smaller ones from executing. For queries that return large amounts of data, we have created Cloud Fetch to write data to a temporary location, and then upon completion of that, ingest it into your BI tool. All of this is powered by Photon, and it's in public preview today. In order to grant access to Databricks SQL, an admin must first create a SQL endpoint. Users are granted permission to use the SQL endpoint, and all of their queries are audited. Creating a SQL endpoint is super simple. Behind the scenes, all you have to do is just fill out this one screen we show here, but behind the scenes, Databricks is automatically selecting the best VM types. We're automatically tuning the config to make this optimized for SQL, and we're automatically scaling the clusters to meet concurrency demand. We've worked very closely with our BI partners to make sure that you can easily use your tool of choice with Databricks SQL. I've already told you a lot in the past about Tableau and Power BI, but the ecosystem is a lot larger. We've partnered with these BI tools to create name connectors, and our name connector is going to, one, make it easy to connect to Databricks. Number two, make it easier to authenticate using single sign-on. Number three, we've eliminated like the chatty protocols underneath to have a very snappy query experience. And finally, as I mentioned before, if we detect a large query result, we'll automatically switch over to Cloud Fetch so that result can be written out to cloud storage in a temporary location, and then the BI tool can retrieve it from there. And that makes a much better experience. Now, in addition to the BI partners that I told you about, we've also been focused on providing a first-class SQL experience within Databricks itself. So we've talked to hundreds of analysts that use various kinds of SQL editors like SQL Workbench, and we work with them to provide the dream set of capabilities that they would expect for SQL development. We've had a long list of features, and some of those include, query tabs, so you can work on multiple queries at the same time. Autosave, so you never have to worry about, forgetting to press the save button and losing your draft. We've integrated the command history, so you can easily look at what you've run in the past, and much better autocomplete, so that as you're typing out your query, it's going to automatically understand, subqueries and query aliases better than before. We've also added debugging capabilities in the editor. So now you can see the query process, error highlighting, and execution time breakdown, all without changing your environment. So as you're executing that query, you get a real-time indication of what's happening behind the scenes. And of course, we stayed true to Databricks' unified approach with a set of features for security collaboration too, including emailing and being able to set permissions on who's allowed to have what kind of access to various queries and results. Now I'm going to hand it back to Amit, who's going to showcase all of this in a demo.
Thanks again, Jason. So for this short demo, I'm going to show you how Databricks SQL provides an easy and simple analytics workspace experience that uses a familiar SQL-based environment to query and manage data in a lakehouse with a scalable, cost-effective, optimized compute for data warehouse or SQL workloads.
Now, very few tools exist to conduct BI on data lakes. Generally, an analyst would need to leverage Spark or use a developer interface to access data stored in the lake. With Databricks SQL, data analysts leverage a SQL native experience on data lakes to quickly run ad hoc queries to create multiple visualization types to explore query results from a different perspective, build and share dashboards. Databricks SQL offers a fully featured SQL editor that allows analysts to write queries in a familiar syntax. If the analyst has metadata read permissions, the schema browser displays the available databases and tables. The analyst can construct a query by inserting the elements from the schema browser or by typing out the query in the editor. As the analyst types, autocomplete suggests valid completions, and once complete, the query can be executed to view the results. Within the same editor, the analyst can view the results as a graphical presentation of the results of the running query. The analyst can leverage out-of-the-box visualization types and chart types. To provide more context of the work, the analyst can provide a description of the query or the visualization. Often, analysts duplicate prior work and modify it to write something from scratch to support a new use case. As the list of queries grows, it becomes difficult to remember which of those queries contain the statement that's needed. The analyst can leverage query snippets, which are segments of queries that can be shared and reused. To invoke a snippet, from the query editor. The analyst only has to start typing the trigger word, and autocomplete will suggest the snippet like any other keyword within the database. When an analyst creates one or more visualizations, they can be combined with an easy drag and drop dashboard. Dashboards can be manually refreshed or scheduled accordingly. Additionally, the report can be emailed to subscribers with refreshed visualizations. Databricks SQL makes it easy to add charts to a dashboard and share it directly with key stakeholders via a web browser. Additionally, when a scheduled query does not meet a certain threshold, alerts can be defined with certain conditions where an analyst or an operations team can be instantly alerted if there are any changes. For these queries to execute, the administrator sets up a SQL endpoint. This is a computation resource that lets the analyst run SQL commands on a data object within the Databricks environment. Databricks SQL provides data warehouse performance and data lake economics through SQL-optimized compute clusters that directly query the Lakehouse. Databricks SQL endpoints offer a quick way to set up SQL and BI-optimized compute clusters powered by Photon, a native vectorized engine fully compatible with Apache Spark, built to accelerate all structured and semi-structured workloads. These endpoints extend Lakehouse capabilities to better handle peaks in query traffic and high cluster utilization with improved execution for both short and long queries. These endpoints extend Lakehouse capabilities to better handle peaks in query traffic and high cluster utilization with improved execution for both short and long queries. Databricks SQL works great for exploratory data analysis and quick dashboarding and alerting. Databricks SQL integrates and complements existing BI tools like Tableau, Power BI, Click that allows data analysts and data scientists to query data lake data directly within Databricks. To conclude, Databricks SQL allows data analysts and SQL users to query all of the data in a multi-cloud Lakehouse architecture by offering scalable, cost-effective clusters optimized for SQL workloads. Databricks SQL also makes it easy to quickly visualize and share insights with the new and easy-to-use SQL query editor, rich dashboards, and automatic alerts, and be able to connect to a broad set of BI tools for fast query performance. Back to you, Jason.
Up to this point, I've been talking about what's available in the Databricks platform today. Now, I'd like to give you a preview for what's next. Being able to quickly and reliably produce high-quality tables in Databricks is going to have a huge impact on every customer. But all data is not created equal. Today, customers are collecting mass amounts of data in data lakes in the cloud, and it's going to keep growing. Fine-grained data governance beyond the file level has been very difficult to achieve historically. This has led to data lakes becoming data swamps. And to let you know what I mean, the only reason you could achieve data governance was at the file level rather than within the contents of those files. This meant that people with data lakes ended up creating lots of copies of subsets of files to give the right groups of people access to the right data. Duplicating data is expensive, not so much because of the cost of disk space, which has been getting cheaper and cheaper. Rather, it's expensive to enforce reliable governance on top of all these disparate data sets that get created. Because each group has a slightly different view on ultimately the same data, purging this data to comply with a GDPR or CCPA request can become a full-time job. And it's very easy to get lost of, who has access to which data sets. You really want to be able to just write your data into one place and then use it many times, but making sure it's governed in the right way. So, and the other thing is, of course, this data just isn't going into one cloud anymore. It's going into many clouds. And the security APIs that you have to deal with in these public cloud vendors are very low level and they're different across every cloud. This makes it harder to keep everything consistent. The problem is just going to get more bigger and more complex. It's not just rows and columns that need to be secured. Most enterprises also want to share and audit and govern lots of different data products. This includes machine learning models, files like pictures or video files, dashboards. Up until now, there's not been a great way to solve for this in a very unified way. So we're introducing the Databricks Unity Catalog. It provides one interface to govern virtually all your data assets. So you write your data once and you govern it in one place. It allows organizations to standardize on one fine-grained security model based on ANSI SQL standards for data access across clouds. It can federate with your existing data catalogs, and there's no heavy migration effort required. The Unity Catalog, it's going to offer fine-grained centralized governance to all data assets across all clouds through the open standard ANSI SQL data control language. This means administrators can easily grant permission to arbitrary user-specific subsets of data using the familiar SQL language that data administrators are already going to know. There's no need to learn a new low-level cloud-specific interface. Access can be granted to tables, views, but also to individual columns and rows. And furthermore, attributes can be created on the data. In this case, PII is an attribute. And then these attributes and policies can be implemented so that groups of users can only have access to certain classes of data. Beyond the permissions, the Unity Catalog UI is going to make it easy to discover, describe, audit, and collaborate with all your data assets in one place. Data stewards can set or review permissions visually, and the catalog captures audit and lineage information that shows you how each data set was produced and accessed. Discover which data sets are the most popular, where the data originates from, and which downstream systems are consuming it. What's more, Unity Catalog works with your existing catalogs and storage systems, so you can leverage your existing investments and build a future-proof governance model with no hard migration required. For example, you can mount existing data from Apache Hive Metastore or from Amazon S3 and manage policies across advanced security solutions like Immuta or Privacera using just regular ANSI SQL to manage those permissions, all in one place. But beyond managing data in your own data ecosystem, data needs to flow beyond the borders of your four virtual walls to other organizations. As an industry, we often talk about how data is the lifeblood of every successful organization. Increasingly, the road to success is about how data flows between these organizations. Data needs to be gathered, organized, exchanged, and enriched to take on bigger, more complex opportunities. But the systems in place today haven't really allowed this to happen. This is why I'm very excited about our recent announcement of Delta sharing. It's the industry's first open protocol for data sharing. Delta sharing is a new approach to data sharing that is fully open. It doesn't have any proprietary lock-in. It's not restricted to just SQL. It has the full support for data science, and it's easily managed, has easily managed privacy, security, and compliance. Delta sharing will be part of the Delta Lake project under the Linux Foundation. It'll be able to tap into the rich support that's already been built around Delta Lake and also the community that's formed around it. In fact, we've already seen tremendous support for the project. I've got a list here of some of the partners that have already signed up to be part of this Delta sharing ecosystem. In it, users can directly connect to the shared data through Pandas, Tableau, or dozens of other systems that implement the open protocol without having to deploy a specific platform first. This reduces the access time from months to minutes and greatly reduces work for data providers who want to reach as many users as possible. We're working with a vibrant ecosystem of partners on Delta sharing, including product teams at the leading cloud, BI, and data vendors. If you're using other methods for data sharing, that can be usually proprietary vendors where the producer who's sharing the data has to use the same platform as the consumers who are consuming that data. And if those two organizations are not on the same platform already, it can take months for the necessary approvals to get that system in. I hope you're as excited as the work that we're about to doing to advance data management on the Lakehouse. I just wanted to summarize everything we've talked about today. So Delta sharing, it's the world's first open protocol for data sharing and collaboration. It has great ecosystem support already, and we believe it will redefine data sharing in the same way that the Lakehouse is redefining the data warehouse: open, simple, and collaborative. Delta Live Tables is going to make the experience of building reliable data pipelines on Delta Lake extremely easy by taking a lot of the manual legwork out of the process. With Unity Catalog, you'll be able to easily govern all your Lakehouse data across any cloud. And finally, Photon is rapidly making Lakehouse the ideal home for all your traditional analytic workloads. And ultimately, the Lakehouse architecture allows you to do everything from AI to BI. With that, let's get to the questions, and please add your questions into the Q&A box. If we haven't already answered them, we'll get to them right now. Thank you very much.
Great. Well, hello, everyone. Thank you for adding your questions to the Q&A box. Feel free to continue to do that. My name is Sam Steiny, and I work in product marketing at Databricks. I'll be facilitating the discussion today. We have on the line Jason and Amit. So I'm going to go through some questions here that we've gotten. And again, feel free to continue to add your questions, and we will do our best to get to as many as we can. So to start, Jason, I will ask this one to you. What is the difference, kind of a foundational question, what is the difference between a data lake versus Delta Lake?
A data lake and a Delta Lake?
Yeah, what is a data lake versus Delta Lake?
So a data lake's kind of like have come to existence roughly 10 or so years ago. And what it is a data lake is just it's a collection of files, which could be unstructured files on a large amount of distributed storage. And when it first came out, it was all about on-prem HDFS clusters. But since then, most of the data lakes are in the cloud now. So you're writing data onto the cheapest form of storage, which is blob storage, S3 in Amazon, or Azure Blob Storage, or GCS in Google. And when they first started, it was just a collection of files. There was no ACID transactions. It was basically up to the data engineers to make sure that all the data that was being written was done so in a consistent and atomic way. And Delta Lake came into being, roughly 3 or 4 years ago. And what it did is it created this ACID transactional consistency layer on top of Delta Lakes, on top of data lakes. So that way, whenever your large ETL job is writing data out, you could have atomicity where either the whole job finishes and writes, or none of it does. And that really started to allow for consistency and quality in the data lake. So whenever you write data to it, that either all of it got there or none of it did, and you can start to trust it again. And also allowed us to do things like performance optimizations, where we could skip reading all the files rather than just having to ingest and list all the files, which is a big hit for performance. And it also allows us to do clever things where if we're keeping track of the transaction log of all the changes that are made to data, then we can actually do time travel, which means you can run a query at a point in time in the past, or if you want to, leverage that for a change data feed, now you can see all the changes to that data across time. So that's essentially, a Delta Lake gives you these ACID compliance, schema enforcement, and allows you to do things like streaming, which historically were really difficult to do on data lakes.
Great, thank you. I have a couple of questions coming in about ingestion. So Amit, I have one for you. How does Delta Lake help with incremental data ingestion? Does Autoloader do fresh data ingestion, and how does that work?
Yeah, so with incremental data ingestion, a lot of times you're ingesting data from data that gets written onto blob storage. So let's say someone's writing a bunch of JSON files onto an S3 bucket in Amazon. If you're getting a lot of JSON files and they're always coming in, you want to be able to ingest that into your Delta Lake. So we've built something called Autoloader, which can scale out so that if you're getting a lot of files, it can comfortably handle millions of files getting written onto these blob storage buckets. And what it does is it automatically creates some infrastructure on the cloud side using bucket notifications and queues. The terms are a little bit different across clouds, but they all have similar functionality. So Autoloader is just a single API that will automatically create this infrastructure. And then as files get added to that blob storage, the notifications will automatically trigger Databricks to load these new files, and it prevents Databricks from having to do these really expensive listing operations on the buckets themselves. And then that allows you to incrementally get new files as they arrive. And then when you load them into your Delta Lake, because you've had ACID transactions, you can do things like detect if the same data has already arrived or not. And if it hasn't arrived, don't write it again. If it hasn't arrived yet, then go ahead and merge it in. So by doing it that way, you can then have a nice little history of all the changes that are made to your Delta table. And then you can use Delta change data feed to capture all those inserts, updates, and deletes from your Delta table and carry them through downstream.
Perfect. Great. Okay, Amit, over to you on this one. Are you on the line?
Yes, Sam.
Great. What specifically are the roles of a data engineer versus a data scientist versus a data analyst? And specifically, the question asks, do ETL activities stop at a data engineer?
Yeah, that's a great question. Right, so data engineers are the ones that are kind of managing that data, right? So Jason talked about getting data into your Delta Lake and having Delta Lake manage that. But there's a process of transforming that, cleansing that data that needs to be done before it can be consumed by downstream applications or users, right? In this case, data science or data analyst. The data analyst is the one that's going to take that data, that highly curated data within your Delta Lake, and then use that for analysis, right? Trying to really gain understanding into insights of the business. Whereas your data scientist is the one that's going to look at more advanced, applying advanced machine learning techniques to, understand how to do predictive analytics and other advanced data science work. Does ETL activity stop at data engineering? In my opinion, I think it does. I think your data engineer is the one that is really doing the ETL work and creating highly curated data sets for, like I said, the downstream applications and users.
Got it. Thank you. Okay, now I'm going to go back over to Jason because you spoke about Delta Live tables and Amit took us through a demo there, and we've gotten this question a couple of times. What is a Delta table versus a Delta Live table?
Yeah, a Delta table is, the core foundational component of being able to do ACID transactions on top of a regular Delta Lake or data lake, and so that's what gives you like transactionality and the ability to know that the data in there is complete. And what a Delta Live table is you can think about Delta Live table is almost like data in motion, and it can be incremental in the sense that you're either incrementally updating this table on a scheduled basis, or it could be incrementally updating this table in a continuous basis. And so if you create a Delta Live table, it's almost kind of like a materialized view, but it's persisting data. And as that data is flowing through the system, you could apply these expectations and say, I expect the data to meet certain conditions, and if it doesn't and it violates those conditions, then you can basically flag it up as an error, and you can choose what you want to happen. You can either fail this continuous ETL completely, or more likely what you want to do is just flag this up and have an alert sent out, and then eventually you might want to have this data quarantined off so somebody can go back and look at it. So it's a way to continuously be monitoring and applying expectations to your data so that you can have trust in your data, because you're basically enforcing this data quality without having it to always be like an all or nothing type thing. So because a lot of times data kind of like it starts out being very clean, and at some point upstream somebody will add like a new category, or maybe there's some bad data entry, and you don't want a few bad records to blow up your whole pipeline, but you do want to be aware if those few bad records start to turn into a significant percentage of the data that's being processed.
Great, thank you. Let's see, lots of awesome questions coming in, so thank you to everyone. One for Amit. How does Delta Lake help with CCPA and GDPR compliance? So specifically, how does Delta Lake handle previous versions of data on delete?
that one for me?
Yeah, that one's for Amit. Are you on the line?
You there, Amit?
Oh, you might have lost him. Jason, do you want to take that one?
Sure. So, I mean, one of the challenges with older data lakes is that, and whenever data lakes were first created, there was no such thing as GDPR or CCPA. So, the concept of having to delete or purge data, wasn't really top of mind. And if you think about, you've got petabytes of data, or even really terabytes, it's the same problem. And somebody says like, okay, I want to delete all the records that pertain to a particular email address. The way you physically would have to do that is find all the files that contain information about this particular email address or this identifier, and then basically read in those files, filter out the data for those records, write out a new set of files, and then delete the original file so that you no longer have a trace of this information. And you want to, if you do that consistently, so that you're basically deleting the files at the same time, the old files at the same time you're writing new files, then great. But that's really hard to do. And if you've got queries running against this data set at the same time, it's really hard to do. So older data lakes, people typically would wait until 3 in the morning when nobody's doing anything on the system, and then run a series of steps and then reconciliation to make sure that they did things the right way. And it can be done, but it's hard to do it on a regular basis, and it's very error prone. So with Delta Lake, you can, if you need to delete data, you essentially just run a delete command like you would on a normal database. It essentially does all those operations that I just outlined for you, but you don't think about them. And in this way, this is a good example of how Delta Lake is kind of like a logical layer that sits on top of your data lake that allows you to just think about logical operations like inserts, updates, deletes, merges, and then the physical implementation of those logical commands, get done for you at the file level without you having to think about it, just like you'd expect out of a database, really.
Perfect, great, thank you. And I think we do have Amit on, but he may have been on mute. So I have a new question, Amit, for you. For a company that's thinking about implementing a data lake or implementing Delta Lake, how should they measure the value of that? All right, Amit, I think we're just having phone issues. Jason, you go ahead on that one. How should someone think about measuring the value of a data lake and the value of Delta Lake?
The value of a data lake versus a Delta lake?
Yeah, just a company that's implementing a data lake, how do they measure that? How do they think about measuring the value of adding that into their architecture? And then specifically, how do they think about Delta Lake in that context?
Yeah, I mean, at the end of the day, this, it's true about any type of technology. You have to think about, like, what are you applying this technology for? There's usually some sort of set of use cases, and then those use cases map to some sort of larger initiative. And you can categorize these initiatives of either trying to innovate and generate more revenue before your competitors do, or to streamline and build in efficiencies, reducing cost, something you're already doing. And so I would look at, top line, what are you actually trying to achieve? And then, you can also from there think about, like, okay, well, where does my organization need to be in the next 5 years? And what are we going to have to build in order to stay competitive? And ultimately, it becomes a question of, can you build and execute whatever it is you need to do faster than the competition? And so in that way, it really comes down to, like, speed and innovation. Can I as an organization build what I need to build and do it in a way that's going to be the most efficient, so that I can do more things faster? So for example, like, one of our customers is a pharmaceutical company, and they're in the business of developing new drugs to cure treatments, and they've potentially created a cure to chronic liver disease. And the way they do it is they take all this genomic data and they run analysis on it to figure out, like, which therapeutics they should focus on trialing in the lab. And if they can basically use analytics on their genomic data to narrow that down to a smaller set of trials, they could potentially, get to an answer faster than other pharmaceutical companies. And in the cloud, it's great because whenever you're doing this analysis, you need a whole bunch of compute to analyze the genomic data. And then after you're done, you just can shut it all down. And if you can run more experiments in parallel, you can get to an answer potentially faster than somebody else. And so that's an example of how you should think about evaluating technology. And Delta Lake, I would say, allows you to innovate and find those answers much faster than you could if you were doing it on just a regular data lake, because you're not having to deal, you don't have to spend as much time with dealing with corrupt or incorrect data, or having to fight the battles of, do we trust this data or not?
That's great. Thank you. Okay, Jason, I'll ask you one more question because we've gotten a few of these in the chat. What would you say the differences between a data lake and a lake house? Are they the same? How are they related? And then where does Delta Lake again fit into that context?
Yeah, so again, with when data lakes first came around, they were kind of essentially just augmenting data warehouses. So companies were gathering and consuming a lot more data, and they wanted to put it someplace. And some of that data wasn't really, structured data that you get out of databases, so it didn't fit in a data warehouse. And this is like unstructured data, like JSON or log files. But it's also a lot of times like pictures, audio files, video files. And so the data lake came into being to have a place to put all this data. But when it came to actually running, traditional star schema SQL queries against data lakes, the performance was not that great compared to traditional data warehouse. And fast forward to today, we've developed Delta, and I talked about this transactionality a lot. But what it allows you to do is basically have better performance, because you can now, whenever you run a query, you don't have to scan all of the data. You can intelligently know which files you need to ingest and which files you can skip. And that's just one example, but there's a load of different things we've done to improve performance. It's all built on top of Delta Lake. And now whenever you want to run those traditional star schema queries, you can do it against, a Delta Lake and Databricks and have, the same, if not better performance than a data warehouse. So now that the performance, has basically, that gap has been narrowed or eliminated, you have to ask yourself, well, if I've already got all this data in a data lake or a Delta Lake, what is the benefit of exporting that data out to a data warehouse and now maintaining two separate copies of essentially the same data, and also having to have a different governance model across those two data sets? If I can just do all of my use cases in one place and just write the data once and use it many times, why wouldn't I want to do that? So that's like the big difference with Lakehouse, which, is, I think, really just an acknowledgement of like the performance gap that used to exist between data warehouse and data lake has been eliminated now.
That's great. Thanks so much, Jason. And thank you, Ahmed, as well, for being on the line. That's all the time we have live today, but we will absolutely go through. We have your questions, and we will do our best to get back to you on those. There's also a couple of resources in the portal, which you have access to now if you're on the line. That's the definitive guide to Delta Lake by O'Reilly and cloud modernization with Databricks and AWS. Both super great assets. I highly recommend you check those out. And feel free to contact us through our website or reach out to your account representative for any further questions as well. Thanks for joining, and hope you have a great day.